Welcome to the Affordable Green Demonstration Home. This is a project that was done in conjunction with the City of West Des Moines, Home Incorporated, and Center on Sustainable Communities. This project incorporates as many green building strategies as we can in an affordable green home. Now with me is Bill McAnally, and he's in charge of the education component of this project, and he'll kind of go through what you can expect to see in this video.
In this 10-segment series, we're going to be covering everything from foundations to framing to insulation, indoor air quality, basically the whole gamut of how to build an energy-efficient, healthy, sustainable home.
This project was put together by three main partners: the City of West Des Moines, Home Incorporated, and Center on Sustainable Communities. West Des Moines provided some of the infrastructure and property for the home and was involved in the entire construction process. Home Incorporated was the builder of the project, and they specialize in low to moderate income housing. And Center on Sustainable Communities was the education partner in this project. The process, as with a lot of green construction projects, started out with a charrette. A charrette is really an opportunity for all the partners to get together and discuss the project. This gives us an opportunity to pre-plan, allows us to incorporate a lot of the features for low or no cost. And as we discussed the design, we looked at opportunities for change. What was really important about this project was that we used the plan from a home that had already been built. That allows us to benchmark at the end of the project to really see what these changes did for the project. One of the things we did when we looked at the plan was kept the basic floor plan, but then used the opportunities we had to respond to the site, incorporate advanced framing techniques to save materials and cost, and really look at the best way to get something incorporated for the least amount of money. Now, what was unique about this home was the education component. We had the ability to have class discussion about the home as it was being built. We had a series that was both for professionals and homeowners, which included classroom time, but also allowed us to go on site and actually visit and see construction as it happened. That really allowed the connection between the actual built product and what somebody saw in the classroom.
We really want to have a lot of fun with this, and most of the contractors had a pretty good time. There was a lot of learning going on, which always happens with a new project. Our first segment is going to be foundations.
Foundations are one of the most important aspects in green construction. A basement is something we want you to consider as a livable space. That means it needs to be warm, dry, and has good indoor air quality. During the initial construction, when we excavated, we made sure that the whole foundation sat on a gravel bed. That allowed good drainage and kept the footing dry. One of the next stages we took a look at is before we put the slab in, we put what's called drainage tile to allow us to drain any water that would be underneath the slab away from the home. That was covered with gravel, and then we put insulation down. That will keep the basement slab warm. Then as we connected the foundation wall to the footings, we put in what's called a capillary break. That keeps moisture from migrating through the ground up into the foundation walls. That's very important in keeping not only your basement dry, but the insulation up above in the regular wood construction. As we backfilled, we wanted to make sure that we didn't have direct contact with the wet soil and the foundation wall. So we put a drainage barrier there. That'll allow a space for any water that comes in contact with the foundation wall to drain away from there. One of the other things we did take advantage of is the fact that with that drainage tile, both inside and outside of the foundation slab, we can connect that to a radon mitigation system. That allows us, if we do have a radon problem, to pump that air away before it gets into the home and causes issues with indoor air quality. One of the things that was unique with this particular project is that it was in an area that was an older developed area, and the sewer line was relatively shallow. A lot of these places did not have basements, and so they didn't have drainage issues on the lower floor. We had to actually put in a pump system to allow us to pump any of the waste that is from the basement, such as the floor drain, the washer, if you had a bathroom down here. The other thing you want to take a look at when you site the house is you want to put the foundation wall high enough that as you push the grade back up against the foundation wall, it can slope away from the house. Again, that keeps the basement drier if you're shedding the water away from the house. So when we poured these walls, they were up to 4 foot out of the ground. As we constructed this, that allowed us to keep everything up and out of the mud, but also then when we pushed the dirt back, we could slope this away and keep water away from the foundation. Anytime you excavate for a basement, you'll have additional dirt that you're not going to need because obviously foundation is taking up part of that space. One of the things that we want to look at in all of our resources is to consume the least amount of energy in taking care of them, whether it's recycling or finding another use for them. What we did in this case is we found a couple sources that were very close to our existing site and allowed them to use our excess dirt. That way we don't have all the fuel consumption with shipping that dirt off site.
We didn't get a chance to see the radon pit, and we've gone to all these measures earlier on in some of the earlier sessions where we put gravel underneath the slab, we put poly underneath the slab. That's to hold the radon gas down below so that we can get rid of it out of this pit. We'll be attaching a 4-inch pipe that'll go out through the roof, and we can either do it passively, which means that the gases will rise naturally, or we may have to put a fan on to be able to control the radon that's underneath the slab. Iowa has a very, very high radon average, and so the odds are pretty good that we're going to have to put a fan in this particular unit. Some of the things we really want to highlight, let's go ahead and start with the floor. The floor joists that were put in were I-joists, manufactured materials, but then it was sheeted with Advantech flooring. It's an upgrade of a standard OSB. You can tell by some of the labeling that it has a limited 50-year warranty. But also a nice thing about this particular brand of sheeting is it holds up very well during rains and high moisture. So we don't have that puffiness that you might see sometimes around some of the seams if it's been wet. You don't have any butting up, any swelling along any joints or anything. And this makes it pretty easy for a regular framer and carpenter as well, because all of the on centers are labeled 16, 19.2, and 24 inches on center. So even a homeowner with very limited experience could put this product down in the right manner. Dan, you went ahead and this was all glued and screwed, or glued and nailed?
Glued and nailed.
Glued and nailed. So why'd you go ahead and glue this? I mean, besides just, we always used to just nail it. Why did you glue this?
It keeps the squeaks out of the floor.
Okay.
It adheres better to the I-joists.
Yeah, and it makes a lot stiffer floor, doesn't it?
Right.
So you've got about the perfect floor system to work off of right now. And to make this building more energy efficient, what they did is when they stood the walls up, they used a structural adhesive that we normally would just use to bond the sheeting down to the floor joist. But in this case, they used it when they stood the walls up. So the bottom plate sticks to the floor so that right underneath this area, this was just a guiding nail when they set the wall up, and that'll be coming out later. But this bottom plate then is sealed to the floor. So when we do a blower test later on, it's a pretty good possibility we're not going to have any air leakage along that spot. And in some older homes, that's a significant air loss. So we gain a lot of energy efficiency right there. So when we move from the plate up into the walls, this might look like a long ways apart for most people, but the house is framed at 24 inches on center. And at 24 inches on center, we allow more insulation, less wood, and there's some concerns I know sometimes about, they think, well, wood's too far apart. If you get thrown into it, you're going to dent the sheetrock, you're going to do this. Those are just really a non-concern for us. We're really looking at a high-performance wall. On the outside of the studs, there's 1-inch extruded polystyrene, which is Dow styrofoam. Now, with the 1-inch foam on the outside, what it does is it really reduces the amount of thermal bridging through the stud. So when it's cold outside, let's say it's 0. If it's 0 outside and it's 70 inside, there's a vast temperature difference. So what the foam will do is it slows down and sometimes pretty much stops the heat transfer from outside. So the foam stops it, and then this piece of wood then doesn't act so much as a thermal bridge, because really wood isn't that much of an insulator. And if we ever look at a house with just, say, wood sheeting on the outside, you'll be able to see every one of these studs very well. You'll be able to sometimes even see where the drywall is screwed into the stud because of the cold coming through.
One thing we're going to want to point out is the trusses as they sit on the wall. That part right there is called the heel, and we have that additionally deeper than a typical roof construction. That allows for more insulation in there, and this is a typical area where you have a lot of heat loss. So by increasing that depth, we can put more insulation in there. You'll also notice that the truss lines up directly with the roof framing, or the wall framing. That, again, allows us to carry that load straight down, and we use less lumber in the framing.
Now, when we go ahead and insulate later, we're going to put, sheetrock on the ceiling here, and then since you've already had the blocks put in, what kind of insulation are we going to put above this, and then stopping, any airflow from coming into the insulation from the overhang?
Well, one of the things we're going to do is somewhat of a hybrid system. After the drywall is up, we're going to go ahead and spray the bottom and up along this edge with foam. That will air seal the ceiling and this edge here so that we don't have drafts here rearranging insulation. On top of that foam, we'll have blown-in cellulose. That makes up the difference in the R value, so we kind of get the best of both worlds. We get the air sealing and then the additional insulation.